All right, in looking at this equation, I was watching very carefully to see how you guys were solving this. And a lot of you were trying to add 10 to both sides. The problem with that method is that this really isn't a minus 10. It's really an entire expression of k minus 10 divided by 2. So that method isn't going to work for us. And this is what we talked about quite a bit. When you have what looks like a fraction over this side here on the left, we need to make this side a fraction as well. So if we have a whole number of -7, if you were multiplying or dividing that and you wanted to make that into a fraction, well, you would just slap a 1 underneath it. The denominator is sort of kind of understood to be 1. Once you put that there and you look at the whole picture now, you should see, this looks like a proportion. Remember, we did proportions a while ago. We've got something over something equals something over something. How do we solve proportions? We cross multiply. So when we do that, 2 times -7 is -14. Equal sign is in the middle. And now the nice thing about multiplying anything by 1 is that it doesn't change. It's the same thing. So we still have k minus 10. And now you're really at a one-step equation. So you're going to draw your river and you're going to solve it. When you come over here for your check, you're going to use the parenthetical promise. You're going to put in your value that you think k is, and you're going to subtract 10 over 2 and see that it equals -7. Order of operations says you will take care of whatever is on top first, so you'll get that answer, and then you'll divide by 2 to make sure that it's equal to -7. Now, moving on to the next one, we have a pretty straightforward two-step equation. We're going to draw our river, and we always want to get rid of the constants. So some of you actually asked, can I go ahead and flop around the order? And I said, absolutely. As long as there's a plus sign, the commutative property allows you to do that. And so if you wanted to do that so it looks a little bit more friendly, that's totally fine. We'd have 4r, and then we'd have a -7. And of course, we'd still have an equals and a -15. Once it looks like this, it should come second nature to you at this point that you know you need to get rid of the 7. How do you get rid of the 7? You add 7 to both sides. So we add 7 to both sides. If you had subtracted 7, like some of y'all did, you wind up with actually a -14. -7 minus 7 is -14, and you're more in a hole than you were to begin with. So make sure that whatever you're doing, you're actually canceling it out. So speaking of canceling out, I will draw a big old X through that. And so I'm left with 4r. I'm left with an equal sign in the middle, and then I'm going to let you do the rest. I want you to think about what a -15 added to a +7 would be, and then finish this off by getting rid of that 4. Your check, you're going to keep this equation just like it is. We don't want to swap around the order because if we did this step wrong, then we're not going to catch our mistakes. So let's go ahead and go back to how it originally was. And I'm going to use my parenthetical promise, and I'm going to put in whatever I think r is. Of course, everything else is going to come down. So I'll have an equals and a -15 on the other side. And then the order of operations says that you multiply. So you'll figure out what that is, and then you'll add on the -7 to make sure that you get -15.